All right. First of all, everybody, thanks a lot for coming. Can everybody hear me okay? They're in the back. All good to go? All right. Very cool. So yeah, thanks for coming. Hope everybody's enjoying the conference. I'm going to talk to you a little bit about PunkSPIDER, which is a project for fuzzing the internet. And I'll tell you exactly what that means here in a few minutes. So first off, I'm going to talk to you a little bit about what it is, how it works. We're going to jump into why I decided to build it, why you should use it, and then a little bit about where we are on the project exactly. Then I'll show you a demo. So, hope you like it. There we go. So first off, what is PunkSPIDER? So PunkSPIDER is a distributed architecture-based, open-source, custom-built web application fuzzer unleashed on the internet. I'll spend the next hour explaining exactly what all of that means. So we're attempting to fuzz the entire internet and store all of the results in a friendly search engine interface. All of this is going to be provided back to you for free. So the entire solution is what we call PunkSPIDER. PunkSPIDER has a lot of different pieces to it, some custom built, some based on other open source tools, all that. So I'll be really clear throughout this whole presentation on exactly what we built versus what's based on open source tools. So a little bit of background. Yeah, we're good. So first a little bit of background. So you would think, and I definitely thought this when I was just starting this project, that one of the most important things about crawling web applications and fuzzing them would be bandwidth. I mean, to me, we're transferring stuff over the network. We're not really doing that much to the data once we get it. And then we're just submitting more HTTP requests, right? So you'd think bandwidth is the most important thing here. This actually isn't the case. So actually, we're doing a lot with the data once we get it. For example, one of the checks that we're doing is for some basic cross-site scripting in a site. So we parse the response looking for script tags with specific data in it. And stuff like that can actually take a non-trivial amount of processing power and memory, just depending on how it's done. So anyway, the point is processing power and memory availability are far and beyond more important than bandwidth for high-speed fuzzing. So to me, when I started this project, this was actually really good news. I come from a scientific background. I have a degree in math and physics, so I used to work on a lot of... Thank you, yes. Yeah, thank you. So I used to do work on a lot of parallel computing projects in college. So this was sort of down my alley. Really, if bandwidth had turned out to be most important, I'm not sure what exactly I would have done there. Maybe buy some like larger Ethernet cables or shinier looking ones that look better. So I'm really not much of a hardware guy. So knowing that computing power was more important, distributed computing was naturally the way to go. And this is where Hadoop came into my life and started taking over. So unfortunately, I do have to give you a good bit of background on Hadoop. Just the next 2 or 3 slides, actually, so it'll only take about 10 minutes. Hadoop is an implementation of MapReduce. And actually, I was trying to define this well myself in my own words, but I could never do better than Wikipedia. So I decided to just put the Wikipedia entry on there and read it out to you right now. So MapReduce is divided into 2 steps. So there's a map step where, and again, I'm just going to read this. The master node takes the input, divides it into smaller subproblems, and distributes them to worker nodes. So a worker node may do this again in turn, leading to a multi-level tree structure. The worker node processes a smaller problem and passes the answer back to its master node. And this is where the reduce step comes in. So the master node then collects the answers to all of the subproblems and combines them in some way to form the output. So that's going to be the answer to the problem that we were originally trying to solve. So that's all great, actually. Sorry, I was not on that slide when I read all about it. Anyway, so more on Hadoop. All that really means is that writing distributed computing programs is made extremely easy. It has a few advantages to it, not least of which is that Hadoop is really well documented, it's well maintained, there's a really big, extremely helpful community around it. Another big advantage is that I don't have enough money to spend on large amounts of hardware. And I don't really have enough space in my apartment to keep a bunch of servers, and also servers are really loud and get really annoying in an apartment. I don't know if anybody's ever run into that. Yeah, that guy's nodding his head over there. So anyway, being on a budget, Hadoop has a great feature that it's really highly fault tolerant. So if you're running a job and all of a sudden the node that has a piece of that job just dies, handles it really gracefully, and just distributes it to other members of the cluster. So it's really just a great piece of software, and I'll explain exactly how we're using it for our purposes in just a few minutes. So really all of that means with regards to MapReduce is that we have a list of key value pairs. Key sub 1 and value sub 1 is what we're going to start out with. These are the inputs to the map function that I was talking about. So the map function is distributed across the cluster and yields another list of key value pairs, which here is denoted as key sub 2, value sub 2. So that means the various instances of a single key sub 2 can be elements of that list. In other words, key sub 2 does not have to be unique. And in fact, most of the times it's not expected to be. So the partitioner sets up the job such that all the same values of key sub 2 are logically grouped together. That means that during the reduce phase, the reducer function is going to apply some operation in parallel to each of those groups. So if I'm still making sense to you, that's actually really sexy. So it's simple, it's extremely effective, and we're able to do it really easily. The way we can do that is we use a function called Hadoop streaming within Hadoop, which lets us basically do all of this, write MapReduce programs with pretty much whatever language we want. So we mostly chose Python in order to do that. So it's really great. So all that's good background. Now I want to actually tell you about what our project is doing. So we can move on to PunkSPIDER. So here's how it works. First off, we start off with a simple seed list, which is basically just an initial list of sites that we're going to crawl for links, and then we're going to discover more sites from that. This is basically just your basic search engine spider, which we're indexing. So our seed list comes from a combination of demos and Alexa's top 1 million sites. So we have a few million seeds out there that we're using to collect more data. So when we're actually spidering these sites, all that we're doing is we're looking for new domains. It's a little bit different than like what Google does when it's indexing, in that when Google indexes, they actually go back all the way down into subfolders and they index URLs with parameters and that kind of thing. So all we're doing is we're collecting new domains in this case. We'll be crawling these all a little bit later to find vulnerabilities. I'll tell you all about that in a minute. So Solr. Everything gets indexed back to Apache Solr. The reason we chose Solr is that first of all, it's a search engine backend, and we're building a search engine. So it really wasn't that hard of a decision. Next was that it can be easily sharded. It goes really nicely with our distributed theme. And it's also great because we're going to be storing a lot of records in this, somewhere around 250 million eventually. It's also, of course, really well documented. It's an Apache project, so it's well maintained, well documented, has a great community around it as well. So that's all been really helpful. And I apologize for the joke. So anyway, now we have a huge, constantly growing list of domains. Our goal from here is going to be to crawl them for target URLs and then start fuzzing. So we looked around for a scanner that could handle something like this in a somewhat reasonable amount of time, even just like within a year or so. And it turns out it didn't really exist. And this is where we had to write our own custom fuzzer, which is PunkSCAN. So just a quick note on the relationship between all the things that I'm talking about. PunkSPIDER is kind of the entire solution, so it's the whole architecture, everything. PunkSCAN is just the piece that performs the crawling of domains and the fuzzing of the target URLs, which is what I'm going to tell you about right now. So first off, you might notice that I have a really simple naming convention. That's probably going to stay with everything that I build, just to keep it really simple. So PunkSCAN is a distributed MapReduce-based web application fuzzer. The main unique thing about it is that it's built for stability, speed, depth, scalability, and reliability. And those aren't words that I'm just throwing out there to bullshit you all. I'll actually explain to you exactly how we're achieving all of those. So it makes this happen by, once again, leveraging a Hadoop cluster to run all of its operations. As a quick side note, in PunkSPIDER, this is all run in a completely separate cluster. So we actually have two clusters that are doing things simultaneously, right? So one is discovering new targets, which is just new domains, and one is actually scanning those domains for vulnerabilities. I'll get into more detail on how it's doing that. So anyway, it works first by reading a series of the domains from Solr that are coming in from the other cluster. It's configurable, but generally we're dealing with a few hundred domains in parallel. So we basically just say, hey, scan these few hundred domains. This can, of course, be scaled up arbitrarily. Since we're on Hadoop, we can add more machines to the cluster. We could potentially scan thousands of domains at the same time. Out there, you see clusters of 1,000, 2,000 machines every once in a while, and we could, if we could get to that level, we'd be able to scan really, really fast. So then it starts crawling all of these domains in parallel, leveraging Hadoop. And I want to go into a little bit of detail on exactly how that's happening and how it's doing all the MapReduce jobs. So everything is MapReduce in PunkSCAN, absolutely everything. So if you remember a bit about the discussion on MapReduce a minute ago, it's all about key-value pairs. Our inputs to the mapping function are just really simply a list of the target URLs that we're going to hit. This would be target domains in particular. So for the sake of making this valid MapReduce operation, we're just going to set the key to none and the value to the target URL. So the mapper function, if you remember, is going to be distributed across the cluster. And all this really does is it parses the URL, returns a list of elements with the domain as the key, and a Python tuple of the URL, and a single query parameter within that URL. So we've crawled it, and now we're distributing the job to the rest of the machines in the cluster. So it does this for every single URL and query parameter combination that's found within the domain. So since the key is going to be the domain in this case, the partitioner sets it up so that each domain gets sent to a single node for scanning. So that's really nice for us because basically what we see is we don't have to wait for an entire MapReduce job to finish before we start seeing results. So as a domain is finished, this is all going to get indexed back to Solr, and then, of course, provided back to you. So once it's done, we get a key value pair with the domain as the key and a list of vulnerabilities for that domain. This gets indexed to Solr with a bunch of details on the exact vulnerability. So keep in mind that all of this happens using parallel operations. So in terms of performance, really the sky is the limit. And I mentioned to you that I wasn't just bullshitting you on the stability, speed, depth, scalability thing. We're actually achieving all of that. So stability, because if any of the jobs fail, they just automatically get sent to another node in your cluster. So it really doesn't matter if machines are going down all over the place, which actually does happen because I'm using really crappy hardware in most cases. So if speed comes from, again, everything being parallel operations. The more machines that you have in your cluster, the faster you can go, basically. So if you have a few hundred machines, you could potentially scan a few thousand sites all at once and have it finished relatively quickly. Depth basically just comes from speed. Scalability, of course, comes from the fact that we're using Hadoop and we're extremely fault tolerant in this sense. As I mentioned, nodes go down all the time for me. I don't even have to really worry about it for like another couple days if I don't have time. I can just kind of let it run and everything's still going to work properly. So really MapReduce parallel computing is really perfect for this kind of thing. By the way, if at any point anybody has any questions, feel free to stop me and let me know. No? Okay, cool. So another really nice thing about PunkSCAN is that it's completely free and open source. It's released under the Apache license, so you can pretty much do whatever you want with it with just a couple of restrictions. And please use it responsibly. I just have to add that. All right, so anyway, back to PunkSPIDER. So if you remember, we had just collected a bunch of domains in Solr with more constantly coming in. I just told you about a super cool crawler/fuzzer that can read the domains from Solr, get target URLs, fuzz them, and then index those results back to Solr. So the next step then is actually going to be starting the crawler fuzzer, which is PunkSCAN. We release it in what we call continuous mode, which is basically just the -C flag there. All that means is that PunkSCAN is going to go forever. It's just going to keep looping until it's done with absolutely all of the records in Solr. So it's constantly looking for vulnerabilities in our Solr instance, and it's always going to start with sites that are crawled and scanned the longest time ago. So this means we get a constant, steady stream of new vulnerabilities coming into Solr indefinitely. And again, this can be scaled up really easily. So as we add machines to the cluster, we don't even have to restart PunkSCAN. We just kind of throw the machine on there, start up a few daemons, and it just starts picking it up the next time around that it's going to start scanning a batch of domains. So it's really nice in that, from a system administration standpoint, it's really a dream. I mean, it's really, just really easy to deal with. All right. So now we have a bunch of vulnerability information in Solr. What are we going to do with it now? So we built an API and an easy-to-use front end, which I'm going to demo to you in a minute. And we're going to provide these results to you completely free. So just to be clear, by results, we mean vulnerability information on what will eventually be every site on the internet. I'll tell you exactly where we are in the project, but basically we have just under 4 million domains in there right now, and again, we expect this to go up to right around somewhere between 220 million or 250 million, and we can definitely handle that kind of data with what we have. All right, so I actually just lied to you about something. At the start of the project, I was actually thinking that I would never really allow myself to remove any sites from the index, no matter their affiliation. The goal of the project, which I'm going to talk a little bit more about in a few minutes, is to provide kind of an unbiased view of global web application security. However, at the recommendation of my colleagues and several of my friends, I removed .gov and .mil sites for now, and I'm a little bit ashamed about it, but I had to. So just in case you just walked in, that guy, or weren't paying attention, here's a really simplified view of the architecture. We have my Hadoop cluster over there on the left. I wish I had a laser pointer. We spider the internet for domains. We index those results. We PunkSCAN those domains, which collects targets and fuzzes them again using a Hadoop cluster. And finally, provide all the results to you in a really easy to ingest manner. So that's all great. On the left over there, actually, you can see a picture of my cluster. It's right around, I don't know, 10 to 12 machines or so. Acquisition process for that was really just like go around at work and start asking people for really old hardware. In some cases, this was great, but in some cases, I got hardware that was just completely not functional. So about 50-50 or so. All right. So why would I build this? So I have to admit, a really big part of it is that I was really just curious in how to use some of the new open source big data technologies that are out there. Mentioned earlier that I've worked a little bit on lower level distributed computing stuff back when I was studying physics in college, and this really sounded like fun. It's certainly a lot more fun and a lot easier than working with Fortran 77 on MPI. Really easy to work with. So another thing I really wanted to explore was the nexus of parallel computing and offensive computer security. So in my opinion, this is a field that just has huge potential in the future, and I haven't really seen a lot of work in it so far. If you guys know of projects that are doing this as well, I'd really love to hear about them. So doing this has really just given me a lot of ideas for future projects. And I started a little organization, Hyperion Gray, which is just focused on doing this idea and providing all this back to you guys for free and open source. So last and definitely not least, I really believe in the project's mission. I'll tell you a little bit more about it, but I think the public needs a central location where all of the internet's web application vulnerabilities can be easily looked up and referenced. You'll see all of this during my demo, but some websites have some really dangerously sloppy stuff in them, actually several thousand of them. So we've seen just from our results so far that so many websites have these just ridiculously obvious bugs that make them completely ownable by like anyone that can basically run Linux command prompt, like download SQL map or similar programs and things like that, and just point them to the right URL and just steal a bunch of data. So the end goal is really to inform people so that you all can make educated decisions on what sites you visit. What we're really hoping to see is that eventually people are going to start making better decisions as to which sites they can visit. Hopefully we'll see a decrease in traffic to unsafe sites and an increase in traffic to the safer sites. So this provides kind of an incentive system for folks to actually code somewhat securely, or like at the very least run a basic vulnerability scan against the site before deploying it in a production environment. So one thing to keep in mind, and I think I have a whole slide dedicated on this because some of you are probably out there thinking, this is all really shady. We're not really negatively dinging sites for having relatively minor vulnerabilities, like forgetting to set a cookie with the HTTPS only flag or verbose banners on their web servers and things like that. We're really just reporting back on the dangerous or really sloppy stuff that we think needs to be called out. So just things like really obviously terrible input validation filters or no attempt to do that at all. So all of that you're going to see in a live demo. And I'm going to skip this slide actually. So how can you use PunkSPIDER, and why should you care about it? So if you're a pen tester, how many of you guys are pen testers, do pen tests, anything like that? Less than I thought. Okay. Anyway, so if you're a pen tester, some kind of security analyst of any sort, it's a really quick reference for vulnerability data for a site that you're trying to secure. It's what I like to call getting active reconnaissance passively. So instead of actually having to go out and actively scan a site, you can get all this information passively from my search engine. Another way you can use it is if you're really just curious. So it can be somewhat fun to poke around and see what's vulnerable or not, what organizations have good coding practices, good security practices in general, and which ones don't. Or you can report the vulnerabilities to the web admin or whatever if you're into that kind of thing. If you're a website owner, you basically get a free quick security assessment of your site just by typing in your URL. So I know for a lot of us security folks, it's easy to say, well, you know, they can just run a vulnerability scan. That's not necessarily true in a lot of cases. Some folks just don't know better than to do that. I mean, as you know, pretty much everybody and their mother owns a site these days. There's really no prerequisite at all to know anything about computer security before you release that, and potentially ask for sensitive information from other people, like credit card numbers and things like that. So I do, however, have faith that website owners will, at the very least, do a quick query against the search engine and see if they have some really obviously sloppy bugs out there. I really think that that would increase the level of security awareness for people that actually deploy sites. Another way you can use it is if you're a website user. You basically get a free, quick security assessment of a site that you're either trusting indirectly with your browser sandbox or trusting directly by giving them your sensitive information like credit cards, usernames, passwords, really anything at all. So as I mentioned a little bit, the goal overall is to see traffic for really terrible sites from a security perspective fall and see an overall increase in the security level of the average user. So the next point, as I mentioned, some of you out there are probably thinking that this is a little bit shady, right? We have a ton of vulnerabilities and we're providing them back to you guys, which some of you are dishonest, unfortunately. And so we're providing this back to you. And this could potentially be used for malicious attackers to get into a site. But from my view, we're not really providing anything that's terribly new or novel to a malicious attacker. So anybody can go out there and basically run a really invasive web application scan against the site and get much more detailed information if they're interested in breaking into it. So it's really not a whole lot of new information for an attacker. But for people that are actually coding these sites or sysadmins that are actually managing these sites, we are giving them new information because they might just not have the skill set, time, or funds to get any of this information themselves. So we're providing this back to them, and we hope that they're the ones that are going to use it the most. So a little bit more about our morals. Some things we do that I think are particularly honorable, if I do say so myself, are that we respect robots.txt. In robots, you can set a crawl delay. You can set a disallow so that your site will not get crawled. We do respect that. We don't ignore that. Our goal here really isn't to bring down any sites or to crawl any sites that don't want to be crawled in this case. The other thing we're doing is we're not throwing the kitchen sink at these sites, right? So we're not doing extremely invasive scans or fuzzes against URLs. Really just looking for obvious, stupidly sloppy bugs that folks are having in their site. So there's virtually no chance that we could ever harm a site with everything that we're doing. If you don't believe me, you can download PunkSCAN and check it out. The checks that we're doing really are fairly basic and fairly not invasive, but we still get really good results. So where are we right now with this project? First off, one big important thing that's done and built and implemented is the architecture, as well as the implementation of that architecture. So our hardware is in place, our software is in place, everything's running relatively bug-free. Right now we've been up for a few months. We have just under 4 million unique domains indexed, and this is of course constantly increasing as we speak. We've crawled just under 70,000 of these sites, and this is also increasing steadily. The other day I just added 5 machines to the cluster, so that should help things. The more support we get from the community, the faster we can do this. But eventually it will finish. It's all just kind of a matter of time. So along with that, our front end is fully operational, and we officially released it on February 12th. The The release date was going to be February 15th, so I just wanted to note that that's 3 days early, which is really rare for a development project. Are there any developers out there? Developers? Developers? That guy? Like that guy? Okay, cool. So of course, there's still a lot of work to be done. We definitely need more data. The internet is a big place. We'd like to improve PunkSCAN, start checking for more types of vulnerabilities. It's really big on our radar. We'd definitely like to make the UI prettier for everybody. We'd like to support additional HTTP methods. Right now, we're really just supporting GET requests. We really need to support POST and potentially some other HTTP methods as well. So we'd also like to improve our fuzzing library, release this all free and open source under a separate project maybe. We'd like to provide personal web application scanning upon request for free, of course. Another idea we've been throwing around as of like 12 hours ago is potentially like a Firefox plugin, which will check the results of PunkSCAN and report back to you if it's an obviously unsafe site. I think that would be cool. And if anybody has any other ideas, please feel free to let me know after this talk. I'd really like to hear them. I'm really hoping that this is a community project and that we get a lot of input on this and a lot of support from you all. So we have a lot more ideas. That was just a few. So if you really want to help us, as I mentioned, ideas are always great. The best thing you can probably do is help us out by donating to our Kickstarter. We do have a Kickstarter up. If you go to the main PunkSPIDER webpage, which I'll be showing you here in a minute, there's a little donate button on the top right. That would be awesome, even if it's just like $1. If you can't swing that or you don't want to, you can also just go to the Kickstarter page and click like, which would also help us a lot, assuming that you like us. So some useful links for PunkSPIDER. PunkSPIDER.hyperiongrade.com is the main homepage of the project. HyperionGrade.com is the organization. And Kickstarter.com is where you can donate. So a few shout-outs. Just wanted to thank a few people. Tomas is a guy that's helped me with a lot of coding. Matt has helped me with a lot of testing. Mark, that guy right there, helped me with some code reviews and some useful things. Amanda there has helped me with like pretty much everything. And all our supporters of PunkSPIDER on Kickstarter and ShmooCon, of course. So now we're going to get to the demo piece of it. And was there a question? Oh, okay. Oh, yeah, right? Yeah, check it out. Yeah.
Do you authenticate at all?
No, not yet. No. So if we were, who asked that, by the way? Oh, yeah, good. No, we don't. If we were, for example, trying to brute force, that would be bad. Yeah, that would be bad for us. So we don't do that yet. And I don't think we really have plans to. But this is mainly for public sites. So, all right. So this is PunkSPIDER. All that distributed computing stuff, all that complicated stuff, just comes down to a really simple user interface with a bunch of results. So the first thing I want to point out is that if you're ever using PunkSPIDER and you get confused, there's a link right here at the top that says Search Help. You can click it, takes you over to our Jira, basically helps you along your way. So another basic note, is that right? Somebody laugh at that? Is that the Mario reference? No? Okay. Anyway, another basic note about PunkSPIDER is that we support searching by URL and title. So there's really two main ways that you can use PunkSPIDER. One is you can either be curious about vulnerabilities in a specific site or a group of sites, in which case you could just type that site in here, and I will show you that in a minute. Another way to do it is you might want to search for a large amount of sites with specific vulnerabilities in it. In other words, you can search by vulnerability and say, I want every site that has a SQL injection vulnerability, for example. So right off the bat, I want to show you the second one first. I wanted to leave the ability for the user to conduct massive searches for vulnerabilities if they wanted to. This could be really useful for organizations with a lot of web apps out there, or for security researchers that just want to do research and see how many sites are vulnerable, what kind of sites are vulnerable, and that kind of thing. So if you want to do massive searches, really easy. We support wildcard characters, so you can just put a little star in there. Need this. Let's put this on URL. Click the little spider. And you should get a ton of results back on sites. So this is everything in our index. If you just wanted to see everything with SQL injection bugs, you just really simply check that little box. And it'll search. And we see that we have right around 67 pages of sites with really, really obvious SQL injection bugs in them. That's a pretty good amount. You actually see a lot more if you go to the cross-site scripting. We should see right around 360 pages of results. Yep, right around 361. There we go.
New York Times.
Oh, I missed that when I was preparing for this. I apologize to the New York Times profusely. Not really. Anyway, so remember, all of this is just from scanning right around 70,000 domains. So doing a little bit of math, which I have written down here, but I don't really want to go through, this all adds up to right around 242,000 ridiculously easily exploitable sites via SQL injection. So this is all really obvious stuff. We took an error-based approach to SQL injection, so we're searching for really obvious things like there is an error to your SQL syntax, which actually I'll show you in a minute. That's all we're searching for. So it's pretty light on the false positives, and we're really focused on getting just the most obvious things in here. So enough with that. Let me show you around and get into some really specific examples. So the first example I want to show you just gives you a little bit of background on basic use of PunkSPIDER, along with showing you some of the internal workings of our blind SQL injection scanner. Let me show you this. So this happens to be the Iranian state prison's website. I chose it for no particular reasons. There's a ton of results here that are exactly like this, actually thousands of them. Anyway, basic usage. Yeah, let me show you a little bit about the basic usage for this. So you see a little summary of the site. We see that it has a few, or one blind SQL injection bug and one cross-site scripting bug. So that's pretty interesting, but let's say you want a lot more detail on that. Let's click on the little plus sign, and you get more detail. You get the type, protocol, vulnerability URL, and the parameter that is vulnerable. So that's cool. But let me go a little bit more in depth into how the blind SQL is working. Let me open that in a new tab. Close that. So definitely the first thing I wanted to point out here, I don't want to translate that site at all. So the first thing I wanted to point out here is the front page, which has a really stern-looking man on the front, who he's actually going to be extremely important to us later. And he has a really nice beard, which I'm slightly jealous about. So that's actually going to come into play, all of that, including the beard. So I promised to show you a little bit about how we're looking for blind SQL injection. We're taking a content length-based approach to it. How many of you are familiar with blind SQL injection and how it works and all that stuff? Any web application pen testers in here? Nice. Awesome. All right. So what that means is if you're not familiar with blind SQL injection, we're going to be looking at the page ID parameter, and we're going to check for subtle changes to the web page responding to changes in the SQL syntax. So we see that according to PunkSPIDER, the injection is in the page ID parameter. You can see that right there. Sure if you guys can read that from over there. Can you guys read that? Yeah? Okay. All right, whatever. So in a normal query, all we're basically going to do is we're going to take this. Let me copy this one sec. This would be a normal query, right, to the website. So we have the page ID. We have the page where ID equals 3937, and we should get back that exact same page, which can be identified by this guy with the beard because I don't read Farsi. So essentially what the scanner is doing is it's attempting to inject SQL syntax and look for changes in the site. So over here, if you can't read that, all this is saying is give me the page where ID equals 3937 and 1 equals 1, which is a statement that's always going to be true. If, for example, the site was not vulnerable to SQL injection, chances are this would just look like gibberish to the website, and it would return some kind of a broken page. Let's go ahead and try that out. Should load just fine. We see that same man with the beard, so that's all great. So now what happens with the blind SQL injection scanner now injects something that it knows to be false. So this would be and 1 equals 2. So give me the page where ID equals 3937 and 1 equals 2. And we should see some kind of broken page. The man with the beard disappears, actually. I told you he was going to come in to play, and he was going to be extremely important. So now that he's gone, the blind SQL injection scanner notices that this is somewhat suspicious and reports back that there may be a blind SQL injection bug to it. So we can actually go in and further confirm this if we want to. And let's go ahead and visit page 3938 as opposed to 3937. And we should see a different page because this is just a normal query to the website. And we see another man who looks totally different and definitely does not have a beard. Let's go ahead and inject some more valid SQL. Let's tell it to give it the site the page ID equals 3938 minus 1. So website really has no intrinsic way of being able to do math like that, but SQL database does. So this would be further evidence that we have SQL injection. So hopefully we see the man with the beard. And we do. All right, so that's basically how the blind SQL injection scanner works. Are there any questions to that? Questions there? No?
Run a benchmark, MD5, 1,000 rounds.
What was that? You lost me.
MD5, 1,000 rounds, make it wait a little bit.
Yeah, you can confirm for sure it's blind SQL.
Oh, okay, I see what he's saying. Yeah, yeah.
To get the page response.
Okay, thank you. Who was that, by the way? Thank you. All right, next up. So again, keep in mind the goal here is really to do extremely quick scans. Time is definitely important when you're trying to scan a few million sites, especially hundreds of millions of sites. So that's one thing that we're really going for, is we're trying to do this in the least amount of requests possible and still get decent results. So next up, I'm going to show you another vulnerability, which is much less subtle. And these are ridiculously common out there, actually. As I mentioned, this one's going to be a SQL injection bug. As I mentioned, we expect to have right around 250,000 SQL injection bugs of this type. So these are incredibly obvious SQL injection bugs. We're not going to get into anything subtle, anything that might be mistaken for something else. So we're going to do this. All right, let me open this web page for you. So the web page I'm going to show you is the United Nations Economic and Social Commission for Western Asia. It's my understanding that Western Asia is a fairly large place and that the UN is a fairly important organization. It would be pretty ridiculous if we found a really obvious SQL injection bug in this site. It would mean that they basically have no kinds of practices or procedures for deploying a production site before putting it into production, right? So let's see how they're doing. As I mentioned, nothing subtle, something extremely obvious. I mean, it's not even embedded somewhere in the web page. Like sometimes you get error-based SQL that's just like somewhere in the web page. You got to kind of hunt for it. In this case, it's literally just a blank page. Which says there's an error in your SQL syntax. Really obvious. Let me see. I don't believe we even did. No, we didn't really try any kind of filter evasion for this one either. I mean, it's basically just your standard SQL injection bug. So that's pretty ridiculous. Really, whoever created this site, I mean, they're terrible. Anyway. So last thing I wanted to show you is my favorite piece of functionality, which is a little donate page at the top right. So this takes you to my Kickstarter page. We only have about exactly 30 days left, actually. And we really need your help. So even if it's just a $1 donation, that would be really huge for us. If you can't swing that, just go down here and there's a little like button, and you can like us if you do, in fact, like us. And yeah, thanks for coming, everybody, and hope you enjoy the rest of the conference and that you enjoyed the talk. So questions? Are there any questions? That guy? No, yeah, you, yeah, with the hat. Oh, yeah, I think so. Oh, yeah, I'm sorry, thank you. The question was, have I run PunkSPIDER against PunkSPIDER? Which is totally meta. That's an awesome question. Oh no, hold on, hold on. Actually, I have two URLs here. Maybe not. I thought we had. So no, we don't have PunkSPIDER in PunkSPIDER, but we do have Hyperion Gray's website in there. We should add that to the index, though. That would be cool. Good question. You over there. I knew that that was going to come up, actually. Yes, I'm getting there. Thank you. So the question was, do you see any potential ramifications, keeping in mind the Computer Fraud and Abuse Act in this case? So it's my understanding that that is more for stealing sensitive data and doing something with that sensitive data. In this case, we're actually not breaking into anything at all. We're really just checking for extremely obvious vulnerabilities in sites. And you're shaking your head over there, so am I completely off base on that? What's up? Hire my lawyer, yeah. Oh, hire a lawyer, okay. Surprisingly, no.
Who's your ISP?
So actually, I run this from two different places. So one is I run it in the cloud, and I do proxy everything. And my ISP is Comcast, by the way. And I won't tell you my cloud provider, because I've been kicked out of a couple cloud providers. And I really don't want to get kicked out of this one, because they're really nice folks. So, yeah. So the question was if I run PunkSCAN from the mapper jobs? Yes. Yeah, so the question is if I run PunkSCAN on the distributed nodes. Yes, absolutely. So PunkSCAN is a fully distributed web application fuzzer. It runs on the nodes. So.
What's your ratio of false positives for your vulnerability scan or fuzzer?
That's a good question. There definitely are a few false positives. I can't give you any hard numbers on that, unfortunately. But I will say that, for example, the blind SQL injection one is the one that throws the most false positives. Even then, it's still pretty good. The SQL injection scanner throws almost no false positives in that it's looking for stuff that really just has to be a vulnerability in most cases. The cross-site scripting as well. It's looking for really obvious stuff that indicates a really obvious vulnerability. So the ratio of false positives to not false positives is really good. Any other questions?
What's the worst site you've seen?
So the question is, what's the worst site that I've seen? That's actually a tough question to answer because really any of these vulnerabilities are a big deal. Anything with SQL injection bug here, even if it's just one SQL injection bug, it's just as ownable as a site with 10 SQL injection bugs, if you put it that way. So really any site with SQL injection. To answer your question, there. That didn't run. There we go. All of these. All 67 pages. Any other questions? Nah, there you go.
So have you thought about adding a mailing list option for website owners that could, every time your site scans it so they can be automatically notified?
Yeah, that's an awesome idea. So the comment was, have I thought about adding an email option to email website owners automatically? Yeah, actually, that's part of what I'm worried about. But that is a good idea, though. I mean, essentially, if I really believe in the mission of securing, web applications across the internet, I would just say screw it. I mean, whatever the consequences are, at least I get, hundreds of thousands of sites more secure. Is how I'm looking at it right now. But I might change my mind in 5 minutes. So. What's that? So the comment is, isn't that why I should let them know? Wait, isn't why what I should let them know? Wait, isn't what I... Yeah, no, absolutely. Oh, we certainly can do it. I mean, I'm not I'm not arguing that. We certainly can do it, and I think it's a feature that's definitely on our radar. I'm just not sure if as he said, no good deed goes unpunished. So that's something that we're definitely worried about. But we may do it anyway. So.
Charge them for it and indemnify you.
Charge them for it is the comment, I believe.
And make them indemnify you.
Yeah. Oh,
So you said that one of the goals of your project is to drive traffic away from malicious sites and look towards good ones. Do you have any way whatsoever of actually trying to measure that impact your project has?
sure, absolutely. Oh, no, I'm sorry. So in short, no. We really have no way of measuring if we're seeing traffic decrease to these sites. What we can measure, however, it's a little bit more indirect than that. So if people start or stop visiting these insecure sites, then they have some kind of an incentive to make their site more secure. So we would be able to measure the security of those sites after the fact, put it that way. Absolutely. Absolutely. So the question is if we'll be rescanning those so that we keep the results up to date. Yes. Once we're done with the scan, it just restarts all over again from the very beginning and just keeps going. That's part of PunkSCAN continuous mode that I was talking about. Okay.
So how long does it take you to go full cycle? So when it's done, you just rescan it again. So what's the time frame?
A really long time. So the question is, what's the time frame for scanning every single site and then rescanning it? We don't have a good idea of that right now. We can scan right around 4,500 sites every day or so. The more hardware we get, the more support that we get from the community, the faster we can do it. If we have a Hadoop cluster of 100 strong, 150 strong, we could do this all relatively quickly, probably within a few months, like 7 to 8 months. But if we don't, it's just going to take a while. It's going to just be a matter of time. Yeah.
Do you have any concern that you might be facilitating research for lesser black hats?
So the question is if we have concern for facilitating research for lesser black hats. So script kiddies, basically, that just are going to go on here, find all the SQL injection bugs, and own them, right? Yes, that definitely is a concern. I would argue that if they want this information on a certain site, they could easily get it themselves. So in that way, we're not really providing anything new or novel for them. What we are providing is for website owners that really know nothing about security, don't really know how to run a security scan at all, to help them find their vulnerabilities. But yes, I do see your point, and yes, I could potentially see a malicious.
I don't drive to the library anymore if I go to Google.
Yeah, sure. So yes, that is a concern to answer your question. Yeah.
Some comments related to that. Couldn't you, don't you suit your purpose of disclosing to the public just by saying how many accounts are yes, this is vulnerable, and then disclose the details only to the website owners, but using some kind of authentication like who is information or put this file on your site, okay, now we'll show you the details?
Sure. So the question is why we are disclosing the exact vulnerabilities and additional details on it. So in my view, I wanted this to be a multi-purpose tool. So it's not just for the purpose of helping out website owners that don't know anything about security. It's also to help out the security community and be able to gather this information passively as opposed to actively. Just saves time, basically.
And then it still says, okay, it's vulnerable in these ways, but not the details. If the professional wants to probe further, that's up to them.
Sure, I see. So you would basically want something like
Basically take the plus button away unless they authenticate and said, okay, this is my domain because I put this gibberish HTML file on that you wanted me to put there.
Sure. Yeah, so the idea that he is proposing is that we provide some kind of authentication there to prove that it's their domain so that they can actually see it. That's a wonderful idea. Yeah, we're just not there yet.
Comment to that, which is I think it's pointless. I know that there's a domain that has injectable, nobody's scanning it.
Uh,
But from a security standpoint, I would rather, I'm going to scrape the website on a daily basis so I know what to block. So I know what users are visiting.
Sure. Yeah, so the comment is basically that if you don't want this website scanned by PunkSCAN, for example, you could just block it. Oh,
I'm going to prevent my users going to any of those websites because they're ripe for watering hole attacks and other things that other malware that's going to get on that internet.
I see. Yeah, so you're basically the comment is that he would use the list that you're seeing here as a place to deny websites that you're going to allow your users to use, is essentially the idea. Okay. Yeah, that's a great way of using it. That's exactly how, what we're hoping. Yeah.
So rather than scanning your website like you mentioned, do you have some sort of export tool that I could easily import into a firewall tool set?
Right. So the question is, if we have some kind of export tool that you can easily import to a firewall tool set. No, we don't have that functionality yet. This is the first public release. Those are the exact kind of ideas that we would love to hear, and that's a great idea. So, yeah.
How long do you expect before all those cables are dropped?
I'm hoping that never happens. So the question, yeah. So the question is, how long before we see extremely malicious attacks against websites, to put it that way? Sorry. Yeah, right.
Okay, serious non-tool question. Have you thought about having your Hadoop cluster be moved to other people on the internet so that everyone can contribute?
Nice. So the question is, have we thought about moving our cluster such that we could, for example, sign up additional clusters from the internet from volunteers, right, is essentially what you're getting at?
I'm not going to volunteer.
Right. Well, thank you. Yeah, that's actually a great idea. I would really like to do something like that. Unfortunately, Hadoop is not really made to do that. There's some other projects out there like Boink, B-O-I-N-C, which does allow for something like that, but we would have to port some of our code over. It might take a little bit. No. Doesn't. Yeah, so it's essentially made just for, firewalled off your own cluster kind of thing. So, yeah. Yes, so the question is if the code is made available. Yes, it is. It's on Bitbucket. If you just want to go over there and type in PunkSCAN, you can find it. Download all that code. There's also a mailing list if you have any questions. It's PunkSPIDER@HyperionGray.com. If you really want to know anything about it, I'm glad to answer any questions for anybody that wants to use it or set up their own little instance of PunkSCAN. Glad to help out. So. Over there. Are we out of time yet, by the way? Okay, cool.
I just going to make a comment that like a lot of the issues that people are raising are going to apply to any spider out there because I mean we've seen with this possible with Google's like search query operators.
Right.
As far as like what Johnny Long published and what you can do on Yahoo and Bing and stuff. I mean this stuff is going to get exposed either way, so it's not like this is special.
Yeah, that's it. Well, I think it's special. It's special to me. No, so the comment there for you folks over there is that essentially this is a problem with all search engine spiders, is that they can always be used for malicious purposes in some way. Somebody's going to figure out a way. So he mentioned, for example, Johnny Long's work with Google hacking. That's absolutely true, and I totally agree with that perspective, and you're awesome. Any other questions? Well, I think that's the last one. Yeah.